Hi everyone, we are back and let's talk about neural networks and using machine learning in Mathematica. So there are quite a few basically resource datas and that we can access, and actually you can kind of look up those, but what we're going to do is we're going to look up basically 60,000 training images of numbers and then basically resource data. So images, test data, and we're going to use that to basically train our own and actually build our own neural network and then feed it some example data and see if we can get it to recognize and train it to recognize basically numbers from random samples, or basically numbers from random written samples. So obviously you could kind of think of the different applications that this could produce. So I mean, obviously, the numbers can be extended to text. So if you're trying to basically, if you have scanned text and you're actually trying to transcribe it, into strings, you can kind of imagine that. Obviously, again, we brought up before kind of this idea of perhaps using this for a lot of actually medical applications. So when you're analyzing data and trying to again predict progression of diseases, to identify as you're analyzing and actually looking at an image from some type of medical application, there's obviously things that can be missed. So trying to kind of feed that data through and actually getting that resource, and there's tons of data that can be had. Building these can be very, very helpful for a lot of those applications. So eventually, once this runs, we're going to look at some of the training data, and you see the training data and actually some of the test data as well. We're already basically from this database, we're seeing, okay, 4 goes to 4. It's basically doing the same training that we did previously with our images, except the database is already there for us. And again, Mathematica has several neural nets and databases available for us to work with, manipulate, play around with. You could create your own, again, training essentially that classifier function as well, but I would definitely suggest to utilize what you have available to you. So we can just pick 10 random samples. And again, we're training it. We're saying, okay, this is 2. This is, again, what are the characteristics that are unique and classifying them, tagging them effectively. So net train and net model, there are lots of different net models that are available to you. So neural nets that you can work with that have different data sets. So obviously the MNIST data, that's basically these numeric values as well. You can look at essentially guides, and actually this neural network repository is something that's very helpful. So you can see all of the different neural nets that are available, and obviously there's documentation as well, but you can see what you can possibly do here. So there's lots of classification here, person's age from the image of the face. We've actually used some of these in already predefined values as well. Identify the action in a video, and you can click on a number of these and actually see how you can actually utilize it. So for example, I want to do, I'm just trying to look, I'm trying to look at a cool one that I would want to use. I like a lot of these. I actually really like this one. I want the Van Gogh. This is a cool one where, again, you can actually take a photo and use a neural net to transform it into like the style of Van Gogh Sunny Night, or Starry Night, excuse me, Starry Night. So there's lots of kind of cool things that you can do, and then there's a whole repository for you that you can work with. So let's get back to what we have. So we can take a net model. So this is actually a net model that's trained essentially to basically take this data and build a neural net from this data repository. So we can use this net model, give it training data, and then basically the training data is what we have here. So that repository, some test data to validate. So train it, basically, I want to use this net model, train it on this data set, and validate it on some test data. So excellent. It will now run through this. This may take some time. Maybe, hopefully, maybe not. But now I can actually test my model. So I have, and I pulled out, basically these random numbers and images that I've pulled. And actually, you can see essentially and watch how this works. So we're actually training this ourselves on this data set. So this can actually and may take a while to basically fully go through. But it will train on the data set. You can see here, it's going through the batches, and it will do multiple rounds through this. So we're going to let this run a little bit, and then once it's finally done, we'll actually test our model. So we'll be back in just a second. So we are back, and we finally have our net train, and our model's been built. So let's test our model, our neural network. So here's our model, and let's test our results. 1, 2, 4, 5, 3. Fantastic. And you can actually look at the probabilities of these models forming as well. Now, you can train and develop your own neural network, but as we saw there, net model, that was in our repository. So what does that mean? We could actually, I could actually use this net chain model, so I could just bring that in, and this one has actually already been trained on that data set. So instead of going through the manual training and actually going through multiple rounds, you can, if you're lucky enough to have a repository or a neural net that's already been trained for what we want to do, and you can look at that based on that repository as well. I can now do, and you can see the, basically you can see the syntax that we have to use here. I could just apply my net, my net on my test model, and I get my results, 1, 2, 4, 5, 3. Excellent. So much faster, but again, you could use the same kind of idea to train on your own data set or use a pre-existing model. And that is it. Computer vision, machine learning, neural networks, the possibilities are endless with Mathematica, also in engineering as well. So I hope this has been informative. We'll see you in the next video. Thanks.